So, hello everyone. As it was already mentioned, my name is Armin Pašalić. You can find me on the internet as Krule, and I work in a company called Solaris Bank. We are a banking company, mostly tech company with a banking license, actually. We're half-half, mostly software engineers. So, if anyone is interested about the stuff, we are hiring. You can come talk to me after the talk or at the party later. I have to say this. So. Today I would like to talk about a few interesting concepts that I have picked up during the last few years, I would say, and found extremely useful when tasked with crafting resilient software systems. So, without further ado, let me start with an application containing multiple modules implemented in a single code basis. The approach to building applications such as this is also known as a majestic monolith. Well, I'm kidding. It's known as an N-tier architecture, typically represented as a three-layered architecture. We mostly all know what this should mean, and this is a very simplified representation of it. In general, when a client wants to make some changes, a request is issued, after which the client is put on hold. Application then validates the data, does the processing, and at the end persists the result. All fine and dandy. This result mutates the state, or what was up to this point known as current state. And additional query usually is performed against the database for some reason, which fetches this mutated state and returns it to the client. This is what some people would also call a request-response cycle. This is pretty straightforward and simple, and for most applications is actually perfectly fine. However, in some situations, when the application that we are building, or actually a business domain that we are trying to describe in our software, is extremely complex, or we just have built already a very complex application and we are finding it very hard to reason about our code. Or situation also arises when we want to increase the scalability of our system. Or we just want a system with superpowers. So, the very easy thing we can do, and one of the things we can notice immediately, is something called read-write disparity. What this in essence means that for most applications we have much more reads than we have writes. Although some applications might have more writes than reads as well. So we can structure an application in a way that commands are issued to the write or command endpoint, which validates the user input and immediately responds with either a validation failure or a location of our query or a read endpoint. This depending, of course, what kind of interface you are using. For this example, I'm using a typical HTTP interface, but this actually doesn't have to be the case. So, but let's proceed with this. Response usually contains unique identifier, and our client is usually redirected to this read interface. But this can happen at any time in the future. Because in most situations, clients that have sent you some payload to write already know what they have sent. And they usually know what the previous state was. So, in essence, there is very little reason for writer and reader to be the same. Except in situations where they are taught like that, and they just want to check if this already has happened, which is kind of something that we have been taught for some time to do, and might be not the most correct thing to do. But essentially, at some later point in time, this client might come and say, okay, I have this identifier and I would like to check what's the state. Then the database query would be made, and it would respond to our client saying, okay, this is the state. Now, this looks like a very simple thing to do, and in essence it is. And when we cut the extras, we can actually see what the new application flow of the data would look like. And that's a bit different. But the concepts behind this optimization is known as CQRS. And we have been talking about it for the last couple of days. And it has been mentioned, but no talk has actually described it, at least here. And sorry if you already know about it, but I just had to do it. So what is CQRS in essence? Well, there is another concept called command query separation, or CQS, which was devised by Bertrand Meyer and described in a book, Object-Oriented Software Construction, in 1988, which is 30 years ago. But if you read the slide, I think you should agree that this concept or principle still holds today as much as it held back in the day. Applying the very same principle on a service level is what CQRS is, in essence, is. The term was coined by Greg Young and first publicly mentioned on his blog in 2009. If you have not heard about Greg Young before, which I seriously doubt if you're on this conference, I can only recommend that you go to YouTube, search his name, and watch his videos. You will definitely learn a lot. And digging deeper, we can notice that requirements we have of our write model can differ significantly from those that we have of our read model. While write models tend to implement some complex business rules, complex business logic, read models are in essence just simple queries that you can do against your persistence and just display the state that you have previously prepared. So, these can be modeled to satisfy specific business. Okay, sorry. Can you hear me well? Yes. Okay, thank you. These can be modeled to satisfy specific business requirements. So you can have multiple views on the same data structure using, for instance, something called materialized views in the databases. And with this, we essentially can split our application into two self-contained parts. Now, I would like to make clear that while this specific concept can be very useful in helping transition from monolith to some sort of the service-oriented architecture, or what we call microservices these days, you can still look at this in a construct of a single application as a homogeneous entity. And this is perfectly fine. But it doesn't really matter, it's just an implementation detail. However, if we decide to split our application physically into multiple parts, we get one thing as a very low-hanging fruit. So we have unlocked our first superpower. It's called a ruffle scale. It's not much of a power, though. But before we proceed, I think it's important to mention two things that some of us either take for granted or not spend much time thinking about. One of them is the very idea of the current state. In systems dealing with data, we commonly mutate this current state all the time. But maintaining only the current state comes with some drawbacks. The most obvious one is that every state mutation will effectively remove knowledge about prior state. So in essence, things get forgotten. Other interesting drawback becomes more apparent when dealing with distributed systems, where it is a major challenge to atomically update the databases and publish an event. Distributed transactions are possible, but come at the cost of performance, which ironically is usually the main motivator to move your architecture to a distributed system in the first place. But there is another way to take a look at the current state. If we look at how databases work in the background, we will come across a term called a transaction log. So I will just read from Wikipedia, which is source of all knowledge. It is a history of actions executed by a database management system used to guarantee asset properties over crashes or hardware failure. What we think of application current state seems to be, in essence, in systems that are supporting it, just a product of sequence of events that introduce changes to the state in the first place. That kind of makes sense. To some of us, a concept of eventual consistency, which is the other concept I would like to talk about, is a foreign thing. But it's all around us. Real world is actually eventually consistent. And once we start dealing with distributed systems, we need to accept and embrace this fact. Let me give you an example. In Germany, where I work, in order to deal with taxes, there is a system called Elster. So, in order to do your taxes and to get the specific keys, you go to that website and subscribe. You enter your details, and you get a response. Everything is fine. You will get your username and password in 7 or 8 days via post. And that's perfectly fine, because it allows you so it's their security feature, but nevertheless, the credentials are issued via the other medium. So this could have been, if we had Google in, I don't know, 1900s, and you type in a search at your local telegraph station, then it would get processed by another telegraph station at Google. They would go, search the books, find something, and say, okay, we will send this to you via Postal Express or something. So, in general, I mean, things have changed since 1900s or earlier, but we as software engineers take this immediate consistency a bit too seriously. It actually doesn't coincide with what the real world is about. So, once this becomes apparent and once you're fine with it, you can do some stuff about it. But let's just continue. If we apply these concepts on the system that we have been developing or partitioning in this talk, and instead of persisting a state, every time some business relevant event occurs, we just publish an event inside of some persistence layer which is capable of managing this. And as events are facts that have already happened, and this has been mentioned in this conference for the last 2 days, they are immutable. They are not supposed to be changed ever. And thus our store only allows append and read. Event store can then trigger the projectors. Do I have this thing? Yeah. These are the projectors, or maybe for those who are looking at the other side. These projectors can then project the desired state. And now, in the interesting fact, this state can be projected into anything. We can project the state in a graph database, or in memory, or we can just use part of the state, which is perfectly suitable for the specific business component that needs the state. And I will not talk about event sourcing a lot here, just the benefits that we gain from it. Essentially, what we do every time is build a memory representation. Sorry, I need some water. of the state, replaying events for the specific aggregate. And yeah, sorry. So if you look at the command part, we have a domain model, which is a command model. And how this process works has been already described by Nathan yesterday, but I will just repeat it for brevity's sake. So essentially, once you get a request, you can treat your HTTP request in this manner as a command. Or you can produce a value object, which is a command. It's up to you. It gets into a command handler, which takes all of the previous states based on this command, says, okay, this is for the aggregate ABC. Okay, ask the event store to give you all of the events that have been happening on the ABC aggregate. You replay them in order and essentially construct a current state in memory, which you can use then to apply the new event which is produced from this command. And if this event or this aggregate now satisfies the requirements of whatever business logic that you have, then you can persist a new event and just go on with your system. And we do this on every request. Now, the question has been raised, is this slow? Well, let's take a look at the principle of a bank account. So, my bank account has maybe 100, 200 entries per month. If we take this in a 10-year period, maybe we can reach 200,000 entries. How long does it take to do a left fold on this? Or in Ruby terms, how long would it take to do inject on 100,000 items? I have measured. Approximate, it's below 1 second. And this is just on the right part. So, in essence, this is not slow. There are some domains, business domains, like advertising, which actually process petabytes of data per day. In these cases, there are some optimizations. And this has already been mentioned, and these are called taking the snapshot. And I will not go deeper into it. It has been explained yesterday. Essentially, applying the concept empowered our system with one new superpower, which is ability to time travel. Keeping all the business relevant facts for the lifetime of the system allows us a multitude of things. Most obvious is ability to project state from any previous time. Want to know what was project state 3 weeks ago? No problem. We can construct a special projector which will satisfy the requirement and allow us to do temporal queries. The second ability we have gained is ability to foresee the future. Otherwise, in comic book world, known as precognition. One more ability system gained is features can be constructed as if they have been imagined on the first day, as long as we have relevant events. So imagine a situation if you work in a e-commerce business, and one day a manager comes and says, look, we have a promotion and we would like to send an email with a promotion to every customer that has put a specific set of items in a cart and then took them out during the last year. And in a classical system you go, okay, I need a drink. And then you take a deep breath and explain to your manager that this is not possible. He can have this feature for the next year if he wants, but right now we have somehow lost all of this data. However, in this kind of system, you just say, okay, no problem. We'll just build a projection because we have all of the business relevant events. They have already happened and we keep them in our system. This is quite a powerful tool for such a simple concept. Next is Another superpower, it's all about superpowers, it's a total self-reconstruction. So if we take a look at the state, I have read an article on Reddit some time ago about junior developer who on the first day came and dropped the production database. So poor fellow was subsequently fired by CTO. I'm not going to go into it, except to say I'm very much against. That was a perfect learning opportunity, which cost a lot as well. But if you have your event store and you just keep events, and this is protected and backed up, then you generally have no reason to worry, unless you allow people to drop your event store, which you definitely should not in any case. But if this junior or this company had applied the principle of sourcing events, reconstructing what was known as their current state would have been trivial. And they would have a complete recovery within maybe a couple of hours. It's bad for customers, but still better than losing all of your data and not having any backups. So this also brings other benefits. In general, when I was still working with Rails, which I thankfully don't, there was this concept of migrations, which is actually pretty great. You write your code in Ruby, you run the migration, your schema is changed. Some people use it also to populate the state. I can tell you this is not a good idea, but let's leave that for some other talk. In any case, if you have an event source system, you don't do migrations. I mean, you don't have to. You change the schema of your projection, and you just build a new projection. You populate new projection. You boot up your application, and you just redirect it to read from the new projection. The end. All projection can just be abandoned, destroyed, or repurposed, whatever. If you have no need for it, probably just destroy it. And the last superpower is enhanced charisma. So I come from regulated industry. I work in a tech company that is a bank, so we are very regulated. And if you have regulators come in and say, okay, how do you build software? And you say, we have this thing that we call ledger, and we project everything from the ledger. And they are super happy. So we gained at least +5 versus the regulators. So they're going to love you for this. There are some other benefits as well. Debugging on exact state, again, we have time traveling, is actually very useful. We had a situation where we had a race condition because several different systems were writing to event store, actually business relevant events, which we were synchronizing with external party. And since we made a mistake, it would have been really hard to find this thing because race conditions are notoriously hard to debug. We actually managed to do this in 5 minutes or less. We just brought the state where it was before the bug has happened and just replayed event after event, trying to figure out what happened. It went without a hitch. Problem solved. This is something I would have spent maybe a week previously just working with current state. The second one is testing without updating and deleting things is very nice. Your tests become simpler and faster. Just try it. I can't just describe it enough. And the last one is backing up your system on a per event basis is actually trivial. You build a projection or reactor which can take every event that has happened on a system. Of course, you track the global identifier to see if every event is actually happening. You have some things that are managing these. But it is like having multiple redundant backups at every time is becoming really, really easy. And This was me when I first heard about these concepts. And my first reaction is, why has no one ever told me this exists? Why people don't teach this in schools? I mean, we are being taught techniques in software engineering that have been taught like this for, I think, last 40 years. And this is not something new. As Greg Young would say, double entry bookkeeping, which is essentially a ledger, has been with us for 500 years or more. I'm not sure. I'm not very good with dates. So why is no one teaching about this? I think it's very useful if you have this. This is a powerful yet very simple tool to have in your tool belt. Okay. Please note, you can apply CQRS and event sourcing concepts separately where you feel the need for them. However, I would like to stress, and this is my personal view, which makes it no less correct, while CQRS can fare quite well on its own, event sourcing only makes sense if you intend to build a state for a query from a stream of events. And by definition, this is also a CQRS implementation. I have had a good fortune to encounter a system where event sourcing was applied only for a reason of keeping records. And state was updated and read directly from a command model via transaction. And the presumed reason for this was to reduce complexity. What actually happened, and what was the result after a few months of engineering on this, that complexity has actually significantly increased. We had a huge logic in our workflows, which is a concept we use in order to describe the orchestration layer of the things. And while it resulted in less system objects, complexity was increased so much. Removing the immediate state and applying CQRS patterns to it proliferated classes significantly. So we had lots and lots of new system objects, let's say. But these were focused. These system objects had single responsibility. They were super easy to test, super easy to reason about, and system was working flawlessly. Of course, nothing in software engineering comes for free. And there are always trade-offs. I've heard this a couple of times during this conference. One of the most significant ones, except ones that are mentioned by, again, Nathan, is a mind shift. While this all looks easy and fine and dandy, getting, especially, and I have to say the senior software engineers, to shift their mind view from writing the current state to projecting the state from a series of events is actually a major challenge. It's really, really hard. And as a first example, I will take myself. It took me a while to completely, I mean, idea was fine. It looks so good on paper, but actually in practice, it's not so easy. It takes time, it takes practice. I was lucky enough that the company I worked for has actually invested time in research. We were not actually required to produce a live system for some time. We were given time to research this thing, and this helps immensely. The second one is connected to the first one. Hiring and training engineers in these kind of techniques is not that easy. Especially finding engineers who have previous knowledge of the concept is really, really hard. So if you want to have a system that is going to work quickly and you are a startup, you probably don't want to apply these techniques. Because and I haven't included this, the curve is actually pretty weird. You slow down significantly at the beginning. If you have time to wait for this to realize, actually your development speed is going to increase significantly down the line. And it should. I don't say it will. And the third one is the eventual consistency, or especially when dealing with legacy systems. While eventual consistency is nice, and if you embrace it, should help you, embracing it is not so easy, especially if you're dealing with external systems. And that's why this concept of reactors that I mentioned, we have a concept that projects the state, but we also have a concept which will communicate with external systems, and these are called reactors, and they react to certain events happening, sometimes even by building the state. So these two can be intermixed. But still, sometimes it helps to reason about your external systems as just another persistence repository. These are not the problems you cannot overcome, it's just sometimes really hard. In practice, and I would like to offer some cheats that we discovered while developing systems like this. First one is projectors and reactors should, dare I say, must be idempotent. Idempotency is not that hard to achieve, but at the same time can be tricky. I will not talk about specific implementation. Nathan mentioned some, so he saved me some time. The second one is aggregate scope sequence number. So no one told me when I started that this is a requirement, but in order to avoid weird stuff like events coming out of sync from different systems because you have multiple instances of your write model, this can help you a lot, especially if you use a store which supports constraints. In general, I would say Postgres is quite a nice thing, but you can use other systems. And this is something you should know before you start practicing, because every event has a global identifier, global order number, but it should also have a locally scoped number, scoped to the aggregate itself. Reuse command model aggregate for response when must. I have no idea why I put this. Yeah. So this is really a cheat. So in essence, when you build such a system, you have your interface, and underneath it usually is a message bus of sorts. So you just construct your command, serialize it, put it on the bus, and there's a command handler somewhere down the line. So you decouple your system, and it's pretty nice. But if you skip the step of having a command bus or event bus or whatever, you can actually build your aggregate, and if you're dealing with legacy systems, you can guess what the response is going to be before you actually write a projection. So you can construct your exact response as it should be for your client, which actually expects a response, and this is a requirement of a system. While you at the same time teach them not to expect it, still, it's a good cheat. Command UUID is good for deduplication. In our system, commands carry a unique identifier. If you put it inside event as part of the metadata, you can use this information in order to skip sourcing duplicate events, as long as your commands and events have a one-to-one relationship. And lastly, use Saga to deal with the refactor synchronization error, with reactor synchronization error. There has been some talk about Saga or distributed service manager. I forgot the second name. I'm a bit nervous. This is my first time speaking in front of the conference audience. So Saga pattern is something which enables you, if you're dealing with external systems and you send something and this external system does not support idempotency, how do you deal with this request has timed out? And you actually don't know what has happened. You don't know if the external system got a command to do something or not. Or did it do anything? So you have a whole system that actually just does this. You have an external system which will go, after a while, check if this has been written. If it has, it will source an event. If it has not, it will reattempt. Or if this error persists, it will do something like send an email to an actual person to go and call someone on the phone and ask what is happening in the system, if it's a business critical system. Sometimes it's fine. But you have a whole system that's actually just purposely built in order to deal with errors. So that's it. I'm done. Thank you very much.
In this command pattern, if you implement a project with commands, do you actually save commands in database? Like, is this the because I'm the totally object-oriented developer, right? So I know that users are in tables and so on, right? So you have something like abstraction in separate database for models like that, like tables, old-fashioned tables, and also you need to actually store those events, right? Like commands. So in big systems, you will end up with a table with millions of records. Is that okay?
Yeah, that. Well, there are multiple questions here, I would say. So first of all, storing the commands. To be honest, I'm not storing the commands. I log them into a logging system. However, speaking with Nathan, they are actually sourcing the commands as well in Eventide. So it's up to you. Is this command something that's business, like is storing the command itself something that's business relevant? So if it's relevant for your business, go ahead and do it. If it's not, events are actually what has happened. Commands are intent for something to happen. It doesn't necessarily mean that if I tell someone, go get me a coffee, that he will get up and get me a coffee. So this command has gone away. We don't actually care about it. However, there are some systems where recording this is actually important. So again, trade-offs, it's up to you. And what was the second part, sorry? Okay, thank you very much.
Any other questions? Okay.
The second part was storing a lot of events in the database. So yes. What will happen when there will be, I don't know, write-heavy system, really lots of events? Do you compact them, or do you somehow snapshot them, or do you keep them forever, ever?
Well, there are multiple techniques about this. So depending how large traffic does your organization receive, which is a business relevant. So some companies would use, for instance, Kafka for storing events, which I don't recommend, to be honest. I heard some horror stories about it. And you can do log compaction on it. Some systems like financial institutions have obligation to essentially close their books at the end of the year and say, okay, this is done. We can snapshot the entire system from this point on, store this in some external S3 maybe, or capable, like just get a hard drive and write it on hard drive, and just continue from that point on. It's important to have the ability to build your state from the points that make sense. In general, financial institutions don't deal with this much data. So for us, it's fine. Disks are cheap. But if you're dealing with mobile advertising industry, in general advertising industry, this might become a problem down the line. So different strategies are employed based on what your business focus is. Does this answer your question?
Yeah, more or less, but maybe precise. Let's say you are in the advertisement business. Would you like try to pick a strategy, like find a business relevant division strategy like you described in bank or accounting when there is the end of the year? Would you like put this approach, let's ask the business and let's figure out in which business relevant points we could snapshot, or just let's find a database that is big enough so I can store all the events forever and disk are cheap, so you know.
So well, you can go to Amazon. They have some cheap disks, but from what I know, and I used to work in advertising industry by chance, so information about the campaign is only relevant for the duration and after the campaign itself. After you present a report to your customer, information about clicks or visits becomes mostly irrelevant for you, so you can do log compaction from that point on, if you decide to use event sourcing in this kind of business. When I was working in it, we were not. We were using something similar, but still different enough to not call it event sourcing. So we use Kafka, we projected things inside Kafka, and we just compacted everything at the end, providing we provided real-time reports for our customers. But after the campaign is done, you just compact on this campaign and you say, okay, this is it. Again, depends on the business case, so it's up to you to figure out what and how.
Okay, so then the time traveling works till the compaction.
Well, the time traveling for this specific campaign works till compaction, yes. Because once business decides this data is really, really not relevant anymore because we already got the money for it. But again, if you're in e-commerce business, this is actually a different case. You don't do this because
even if you want to move those events out of your transactional system because it doesn't scale, you can still archive all of those events separately and they can be used to generate reports, and you can still gain the benefits. It's just moving them out of your transactions.
Sorry. Yeah, but that's true. So, any other questions? So, thank you very much. As I have mentioned, my name is Armin Pašalić. I'm found on the internet as Krule. We are hiring, and come talk to me about this because I really love talking about this. And thank you for your attention.